Okay, so we are in Unit 3, and Unit 3 is on collecting data. So we're going to talk about all of the different ways to collect data. So a couple of vocabulary things that we need to know first. We've covered this already. So data can be analyzed as a population, which would be like the whole group. So this population would be a whole group that we want info on. And then we can also do this as just a sample. So if we have a whole group and we pull out just a small sample of people, this is just part of the population. So we can say that this represents a mini population. So just to kind of get our minds set around the difference between population and sample, because it's going to matter when we talk about analyzing data. Here's a few examples. So if we have all Illinois residents, all U.S. high school students, all students at our high school, and then all students in our class. So if you think about a whole state versus all of the high school students versus just our high school students versus our class, you can see how this population decreases into smaller and smaller sample sets, okay? So just to look at this, so a sample of 10 of our school's students, obviously that's our high school. So this would go over here. Our high school would be a sample of 10 students. A sample of 10 U.S. high school students, well, this would be over here. Of all U.S. high school students, we would want just 10 of them. A sample of 10 students in our class, and then a sample of 10 Illinois addresses. This would go here under all residents. So population is the big part. A sample would be a sample set of the whole, okay? Now, this is important. So when we look at analyzing data, we're going to hear two things. We're going to hear statistic, and we're going to hear population, or parameter. So a value that describes a sample. So a value that describes a sample is a statistic. And a value that describes a population is a parameter. Now here's the easiest way to remember this. So statistic goes with a sample. So I wrote statistic here. This should be sample. And this should be population. These are the two things I wanted to write here. Population. Okay, so statistic goes with sample, and parameter goes with population. So think about this. When you see statistic, know it's a sample, S&S. When you see the parameter, or you have a population, you know you're going to use parameter. All right? So if we go down here, identify the population, sample, statistic, and parameter in the following examples. The average height for a 15-year-old female at our school is 5'40". A sample of 10 females at our school have an average height of 5'7". So if we look at our population here, the population is going to be the bigger part, and what this is 15-year-old female at our school. So 15-year-old female at our high school. So the sample of this would be 10 females in our school. Now, the population was 15-year-old females. So the population goes with parameter, and the parameter says that the average is 5'4". The statistic goes with the sample, and that would say that our students are 5'7". So this is kind of how it all goes together. So go ahead and pause the video and do number 2. Okay, so here's what I have. Population's high school. The parameter is that the high school students work 18 hours per week. The sample would be 50 high school students in the country, and that statistic says that those 50 high school students work an average of 23 hours per week. Okay? All right, so now let's talk about how we get data. So we can get data in a bunch of different ways, but we're going to talk about 3 of them specifically in this lesson. And the first one is a study. So an observational study is where researchers just observe subjects and measure the variables of interest. So observational study, we're going to observe subjects and measure variables of interest. We don't, this is super important, we don't influence the responses anyway. So you basically are just looking around or looking at data and you're compiling a list of the results. There are no treatments, which means you don't, for example, if you've got a bunch of students that have headaches and you say, okay, I'm going to give half the students ibuprofen and half of the people Tylenol, and I want to see what the results are. Those are treatments. In other words, with a study, it would be like, okay, we have students that are getting headaches, period. So when we do this, we have two different types of studies that we have. Studies that examine existing data are called retrospective. So that means you already have the data, you're just going to go look at it. So they examine existing data. So retrospective, it's already happened. And then we also have prospective. And prospective data means we're going to track individuals into the future. So we're going to take a list of people, group of people, and we're going to study them into the future. So, they do this sometimes when they tag a whale, and then they just want to see where the whale goes, or tag a fish in the ocean. So they're tracking that individual. And y'all, this is important too. So when we have individuals, this doesn't necessarily mean it's going to be a person. An individual can be whatever we're studying, or whatever information that we want to gather. So this could be plants, it could be animals. So when you see individual, just know that that's what we're studying. It doesn't mean a person. An individual's not a person. Okay, so observational studies attempt to make inferences. So we're going to make conclusions about the population as a whole. So we're going to look at a group, we're going to look at a sample, and then based on the sample, we're going to make an inference on the population. Okay? Some observational studies attempt to study correlation. But remember, observational studies do not imply causation. So, you have seen this before. So just because it looks like there's a correlation, we have to say it doesn't necessarily imply that it's a causation. So we have something that we're going to throw into the mix now when it comes to causation, and that is this concept of a lurking variable. So what a lurking variable does is it makes it difficult to establish a causal link because you can't pull it out of the data. So we're going to talk a lot about lurking variables here in a few minutes, but be concerned about whenever you're looking at data, you have to ask yourself, is there a lurking variable here? So observational studies try to measure things in a natural setting. So you're not necessarily putting things in a lab because what happens, there's no treatment. So we're not doing an experiment, we're just looking at things. And most importantly, when we look at this natural setting, we have to make sure that it's ethically okay, right? So from a biblical standpoint, we can look at things that we do every day and say, okay, this is going to be biblically sound or not. But even in a secular world, we have to look at this. So here's some examples. So you're not going to look at a study or have an experiment where you're going to say, okay, I want you to smoke 2 packs a day and I want you to smoke 3 packs a day and we're going to see if you get lung cancer. Well, that's not ethical, right? Or another one would be, okay, we want you to lose weight while you're pregnant. So we want you to diet and we want to see what the effect is on birth defects. Or we want you to drink and we want to see what the aggressive behavior is. So all of these things are not a good way, so not a good way to do an experiment or an observational study. And I would tell you, just like everything in life, when you're looking at these things, even from a secular standpoint, you have to ask from a worldview, are these ethically, and are these going to be something that go against my beliefs as a Christian, and what I need to do to honor and glorify God in all things. All right, so we have an example here. So for a sample of subjects, you record how many hours of exercise they get each week and the number of colds over a year. You find there is a strong negative relationship between exercise and colds. The more exercise, the fewer the colds. So it tells us right here we have a strong negative relationship. So what we're doing here is we're just observing. All you're doing is you're looking, okay, how you're getting data. How much do you exercise and how many colds do you get? And you're just creating, in this case, probably a scatter chart. So when we have this observation, we are not imposing treatment. We are just collecting data. So when we have an observation like this, remember we're talking about observational studies, you are just gathering data. That's all we're doing. So if you saw something like this on the AP exam, it would ask you these type of questions. Identify the explanatory and response variables. So the explanatory here is going to be the hours of exercise each week. And my response variable here is going to be the number of colds per year. So we have our explanatory variable, we have our response variable. Now, we come back to this question of lurking variables. So, lurking variables are things that could affect this data that we're not particularly going to call out. So, it could be, when you're, and remember, let's go back to this. So, exercise and number of colds. So, it could be, a lurking variable could be your exposure, exposure to pathogens, so something that's going to get you sick. It could be your immune system, so some people might have a different immune system. It could be the type of exercise. So all of these things could affect this negative relationship that we don't know about. So it could just be your effort level, right? Could be your effort level. So how much exercise are you doing, and are you taking care of yourself with diet or whatever? So these things that we have are possible lurking variables. They could affect the data here. So here's another one. So SAT prep and exam. To investigate the correlation between SAT prep and SAT exam within one school year, researchers collect data on a sample of SAT examinees from 3 different high schools. So again, they are just gathering data. So this makes it an observational study. First, the researchers identify if the number of SAT prep classes that these students attended, then they gather the SAT exam scores for each of the students. So they want to see if there's a correlation. So what we have, our explanatory variable is going to be the SAT classes attended. And the response is going to be the SAT exam score. All right, so possible lurking variables. What are things other than just attending the SAT exam or SAT classes that would affect your exam score? Well, it might be how engaged were you in the class? I hate to say this, but it could just be your intelligence. You can go all classes if you want, but if you just don't have it, you don't have it, right? So it could just be your intelligence. It might be the testing conditions. It could be that you were sick that day. So all of these things could have affected your results. All right, let's keep going here. So these are just observational studies. All we're doing is looking at things. All right, so the next way that we gather data are through sample surveys. So a sample survey is a form of an observational study. So it's a type of observational study where researchers use questionnaires or interviews to collect data from a sample to learn about an entire population. So you've done surveys before, so let's talk about what we have here. So opinions or factual information may be obtained depending on the purpose of the study. So this is important, opinions or factual information. So sometimes you can give an opinion. So what is your favorite type of ice cream? Factual information could be, are you lactose intolerant? Do you have to have a dairy-free type of ice cream? All right, so opinion versus this is a fact. Let's see, a census is a type of survey, but is meant to collect all individuals in the population. So census is a key thing, and we're going to talk about that. And the important thing is it's all individuals in the population. It's very different than just a sample survey. A sample survey says, okay, we're going to get the data from the people in our class. A census would be we're going to get the data from everybody in the school, all individuals. The difficulty with a census is collecting all responses takes money and resources and is time consuming. So in the United States, we do a census every 10 years. So every 10 years, we have a U.S. national census. And they go to every single dwelling, apartment, house, everything, and they find out, okay, how many people live in this house? And they do this actual census. And so it takes a lot of time. That's why in the U.S. we only do this every 10 years. Okay. A sample is best when it is randomly selected. So the probability of selecting a sample is the same as the probability of selecting every other sample. So just like when we had our last unit, we wanted things to be randomly scattered. It's the same thing here. We want randomly selected, and you're going to hear randomly over and over and over. And if there's one word that I would tell you to put in everything that we're going to do in this unit, it's going to be this word random. We don't want it to be biased. We want it to be very organic. If your sample is not randomly selected, bias is introduced. And this is going to be a keyword here that we have to highlight. So bias is introduced. So this means that we could influence the study one way or another. So example of a bias. Let's say I want to research whether or not we should have protein drinks. So protein drinks in the cafeteria. And I did a randomly selected study where I went around and asked students. Let's say I randomly picked 50 students and said, do you think we should offer protein drinks in the cafeteria? I am probably going to get a different result than if I went out and asked the football players after morning practice, do you think we should offer protein drinks in the cafeteria? That would be very biased. Obviously, they're going to say yes, right? And so we have to be very careful, and that's why randomly selected surveys give us a better idea of what's happening in the total population, okay? Along with a well-designed random sample, a well-written survey will allow you to obtain reliable responses. That just kind of makes sense. So, well-written survey, this could be the type of survey. Is it better to do this on paper? Is it better to do an email or like a Google form? And then how it's written. So the wording is just as important. What I would put in a survey to high school students would be different than what I would put in a survey to elementary students. Okay? When writing a sample survey, When writing a sample survey, you need to decide the type of questions you want to use. So we could have open-ended. So respondents write comments, essays, or any type of other free response, or we could have closed. So these could be yes, no, true, false, multiple choice. So any type of closed yes or no. So when we create a survey, we're looking for three specific points on that survey. Y'all, hold on real quick. I'm going to turn the lights back on. Okay, sorry. So 3 key points that you want to do when you make a good survey. So the first one is you have to speak the audience language. That goes up to make sure your wording's correct. The next one is you have to keep it simple. If you're writing this big long thing, nobody's going to read it. And the other thing is you have to stay balanced, not biased. So you can't ask leading questions in a survey. Like, for example, if you want to know what type of drinks to serve in the cafeteria, you don't want to say, protein drinks are super healthy. What other drinks do you think we should have in the cafeteria? Okay? So advantages to survey. So we can use various forms to collect the data. It's efficient for collecting data from a large population. So we can say, hey, get this survey done by 2 o'clock today. Can be designed to focus only on response questions, so yes, no, true, false, and we can use a wide range of topics with a survey. The disadvantage to surveys is that you have to expect people are going to be honest, right? Sometimes if you asked a question on a survey, how many volunteer hours did you do this summer? Well, you don't want to say, oh, I didn't do any volunteer hours, because then it'd be like, oh, that looks super judgy. So sometimes people aren't very honest on a survey. And they can be flawed by bias. If it's not randomly sent out, high probability that you're going to have a biased survey. Okay, so we talked about studies, we talked about surveys. Another way that we can collect data is with experiments. And so we're going to talk a lot about creating experiments in this unit. So in an experiment, researchers impose treatment. So they impose treatment on experimental units. Now, remember what we said was that the treatment means we're going to do something. We're going to give some people ibuprofen, we're going to give some people Tylenol, we're going to see whose headache gets better faster. So treatment is what is applied to the experimental unit. Could be a person, could be an animal, could be anything. So these are our individuals of our experiment. So the purpose is to study whether a treatment, that's the whole goal, which treatment, causes a change in the response. So what can we do that's going to change our response variable? When the experimental units are people, we call these subjects. In the experiment, you have to watch out for confounding variables. All right, so confounding variables right here. This is something that is going to be very similar to lurking. Is there something that's happening that is going to bias or change my results of my experiment? These variables may be included in the design unintentionally, or that their effects cannot be distinguished from the explanatory and response variables. And we're going to talk more about these here in just a few minutes. When the experiment is a controlled study, 2 groups are used for comparison. One group of participants is exposed to a treatment, while those in a separate group are not exposed to a treatment, and we call these placebo. Now, placebo is such a big thing. I'm going to highlight this too. Lots of vocabulary in this unit. A placebo is a word that we're going to use, which is just a dummy treatment. You've heard placebo. It's like, okay, I'm going to give you this pill and tell you that it's Tylenol, but it's really not. It's really just some compounded sugar or something. So placebo is a dummy treatment. It's a fake treatment that appears to be, this is the important part, appears to be the same. So the people who are taking this placebo may or may not know that they're getting this dummy treatment. But what we want to do is we want to compare that to the actual treatment. So all experiments, when we're dealing with the placebo, all experimental units need to believe the experience under the same conditions. So what we have is the placebo effect here. And the placebo effect is when subjects respond favorably to a placebo. when subjects respond favorably to a placebo as if it were the actual treatment. So we call this the placebo effect because they've gotten this dummy treatment, something that shouldn't work, but they had favorable results. So they're like, oh, okay, well, this pill worked. Well, they didn't know that the pill was not a real pill, okay? We also have two other types of ways that we deal with the placebo. The first one is called single blind. So what happens in a single blind experiment is the researchers are aware of the subject in each control group, but the subjects are not aware. So right here, researchers are aware, the subjects are not aware if they're receiving the actual treatment. So you would have group 1 and group 2, and we would say that group 1 gets the placebo and group 2 gets the treatment. And the researchers know which is which, but the subjects getting in the experiment don't know which group they're in. All right. The second one that we have is double blind. And double blind, both the research and the subjects are unaware of what's what. So this is the best way to do this because there can be no bias. If you don't know who's getting the result and who's not getting the result, then there's no way for you to be biased to the data. So a double-blind experiment is the best way to do this, okay, if you're going to deal with a placebo. Sometimes that's not possible, though, because we need the researchers to know what's happening. All right. Hey, y'all, sorry, I never do these videos at school, and I'm doing one at school today, and the lights keep going off, so I'll have to keep them on because it makes my screen all grainy. Okay, so here we go. So the best experiments are usually randomized, comparative, double-blind, and placebo-controlled. So this is really like an ideal situation. So what happens is we have these following, and we want to identify is it an experiment or an observational study, and then how do we know this? Okay, so let's do one of these together. A medical team examines the record for 5 large hospitals and compares the survival times of those cancer patients who had surgery versus those who had chemotherapy. So I'm going to ask my question, is treatment imposed? Now, originally you look at this and you say, yes, it's imposed. So some had surgery and some had chemotherapy, but that's not really what happens here. So in this case, no, treatment is not imposed. It is just recorded. So because of this, and actually let's go back and look at this again. So it's just recorded. So what happened here is this is retrospective. All we did is go in and say, okay, I'm going to look at these people and I'm going to just create, I'm going to make it yes or no, they either receive surgery or chemotherapy. So this is an observational study. Now, if we took these same cancer patients and we said, okay, you are going to have surgery and you are going to have chemotherapy and we want to record your survival times, well, now we have 2 different groups that are receiving treatment. So if we redid this a little bit, we could change it from an observational study to an experiment. All right, I'm going to go ahead and pause the video, and I want you to do the same, and then go ahead and answer these 3, and then when you come back on, you can check your results. All right, let's go through these. So with this first one, it's an experiment. So you have half the people that are running, half the people are walking. We're giving them a treatment. The treatment is we're going to see what happens when you run and when you walk. The next one is an observational study. Now, this looks like it might be something different, right? They take a random sample of snakes and record the information on the snake. They're just recording this. They're not imposing a treatment. So here there is no treatment. So you might have different lengths of the snake and the different weight of the snake, but you're not doing anything with this. You're just collecting the data. And then this last one is an experiment. So we're going to tell half of our control group to smoke the same amount of cigarettes, and we're going to take the other half of the control group and tell them to cut it in half. So we're going to have a measurable result at the end because we're going to take their pulses. So we have an explanatory variable, which is going to be our cigarettes, and then we're going to have a response variable, which is going to be what happens to the pulses. So let's talk about this in terms of ethics. So we said a minute ago it's important for the ethics of our survey or experiment, our data collection, to be ethical. Well, this I would say is an ethical type of experiment. So one control group was told to continue to smoke their cigarettes like normal. Well, those people are going to do that anyway, right? If they're going to smoke, they're going to smoke. The other group was told to cut their number of cigarettes they smoke in half. So we're trying to show them here, we're trying to do an experiment where we look at the data of smoking and how bad it is for you. And so with this particular case, what we're trying to do here is get some data. We're not telling them to double, we're telling them to cut in half. So I would say this is ethical, okay? All right, so this was all about collecting data. Now we're gonna go into notes 2. So I'll go ahead and start a new video for that.